I would like to introduce to you our next speaker, Alastair Muir, and he will be speaking on how we create value from oil and gas data. So, sorry, I did not mean to call you Alexander. Alastair.
That's okay. It's actually an Irish and Scottish version of the same name.
Oh, well then, you're bilingual. So, Alastair has been involved in data-driven analytics and business processes improvement for far too long. Armed with a PhD and an open mind, this has taken him around the world as the data guy. He has been at minus 50 degrees as well as plus 50 degrees Celsius and has brushed up against New York mafia.
Yep.
That would be an interesting story. And knows how to steal rough diamonds. Well then, I won't mess with you. Still learning exciting new things. Follow him on his journey from data to business impact in the oil and gas industry. What can you do with all the well-logged data? Without further ado, the floor is yours.
Thanks, Danielle. It was a challenge whether you were going to actually read that out or not. Let's share this. There we are. Quick check. Okay, I'll hide that thing. All right. So, okay. First off, let's think of our office safety and stuff. Everybody can take a little bit of a stretch. You've probably been sitting for a while. It's not just for the safety guys out in the field, but you can do a little bit of ergonomics. Sit up straight in your chair. Okay, there we are. Because I know it's 4:30 on a Friday, and thanks for everybody for their patience for getting this far. So here we are. What I'm going to do is I'm going to take you through a story that pretty well started with this. This looks like the final result. This is a wonderful cross section of well logs all the way through Alberta, looking at the Duvernay and what we're after there. There's the little pinch there is where is the stuff that we're having to look at, and that's where we started off. And we started off by just saying, well, okay, let's see where we go. And the problem started getting bigger. So let's go here. Now, just to take you back to, remember this one is, okay, data, it's the world's most valuable resource, and oil and gas is out. But what I'm going to present here is I think the most valuable resource in oil and gas is data about oil and gas. We can get a lot of stuff out of this. So I go to the companies, and this is what we've got. We've got a lot of data. And usually getting data is not the problem. Part of the problem is getting value out of that. Now you present this to the business partners, and what do they say? Well, yeah, okay, we've got data, but we want impact. This is what we want. We want to be able to put our finger on everything instantly. Now, we've heard about all of AI. Okay, is that the magic bullet? And this is where I see AI fitting in all of this. Is AI, I see as a decision support tool. And what I really liked is earlier on today, Roger Milley said that, in his visualizations, that this was the goal that he had here, is getting all of this data into a well-crafted visualization in front of the right people so they can make a decision. So what we're going to do is we're not going to take AI in this context we're going to make a self-driving car. We're going to make it just a little bit back from that in advising a human being to actually make the final decision. Now, what this does is it puts constrictions on how we're going to deliver on our solution. We'll get into that more in a while. But in the short term, an AI pipeline, I call it, because it is a large process of getting all the way from data to knowledge to insight to analytics, all the way to AI is the last little bit of making a decision. But there's a lot of benefits of having an AI pipeline. it's really hard for one person to handle an enormous amount of data all at the same time. And this is very true of the well log data. We'll get into that. The other thing that I've found is rather than get straight from data to solution is particularly in oil and gas, is this data starts from raw form and it goes from hand to hand to hand to hand. And each individual person or discipline along the chain transforms it into information that's then defined for the next handoff. So this is a little bit different than just getting a bunch of sensor data and saying, there, that's what we're going to do with it. There are a lot of disciplines that are going to be followed to transform this. The other advantage is an AI pipeline can repeat thousands, hundreds of times in a standard, robust, repeatable, objective manner. And this comes very important when it comes to decision support, because a lot of decisions and professional judgments are made just that. They're a recommendation. And it's difficult sometimes to get all of 3 different professionals to agree to the same recommendation. So what we need then is I call it a transformational pipeline. And it's going to start all the way from data, just the raw data. We have to do a lot to get it into information. Then it's transferred into knowledge, and then insight and wisdom, and finally into impact. Now, there are different ways of calling this. You've sometimes seen this is the difference between what is descriptive statistics, then it gets into diagnostic analytics, and then predictive analytics, and then prescriptive analytics, finally to decision. So prediction, and we've already seen some presentations today, this is how I predict this is going to happen. The prescriptive that's more what's going to happen in the future. And that's what's one level further. Now, this is what's going on is sort of, you're concentrating on different things at different stages all the way through. Is you start off and you spend a lot of time on data acquisition. Then you move into merging and joining all these different pieces of information together, summarizing them all, analyzing them, and then finally getting to an optimization. So what I'm going to do is say, we're going to start here on a journey. And this is a very personal journey with well-logged data. We start with an idea, and you search, and you explore, and you learn. There's a huge landscape of things. And you start going down, and in the purple little things, those are all the little dead ends that you say, oh, gee, that looks really cool. That was interesting. How about we try this? And you find out, nope, doesn't work. So just like Kierkegaard said, what I'm going to show here is I'm going to show you life is understood backwards. Is in this little graph here is what I've got is there are over 2,000 different little things that we could have gone on. We started exploring. We've gone through about 750 different individual pieces, many of them dead ends. And that one thing where we got to the solution, there's only 68 steps in that. So I'm cutting out an awful lot of the failed stuff, but it's there. And what we do is we develop a sort of minimum viability product for this pipeline, get some test data, get something, and at least get it all the way through to a solution that's even close to a solution, and then start fixing it after the fact. So where to start? Well, where to start is not with the data. You might think that. No, we're going to start with the business leaders. And some of the other presentations have said this is we're going to figure out, and this is what, let me see. Kelly from Cheddar was talking about, is understanding the difference between the buyer and the user. And what this is the buyer. This is the way the buyer is going to look at it. So let's start there. What are the big metrics here? Is it cost? Is it revenue? Is it safety? Is it environmental impact, greenhouse gases, technical performance of a particular product? It could be maintenance and reliability and time to implement, the amount of effort. And we've seen presentations that emphasize individual pieces like that, but you have to understand that first. Now, once you get this, now, as Kelly pointed out, we're going to go into user mode. is, all right, now that we've established this business plan, we're going to try to figure out how this data moves all the way through. And this is what I call it, a data audit, but it's not how reliable the data is you get the data. It's like a financial audit, is you follow every transaction all the way through. And what we're going to do is we're going to follow that data from the very first step and follow it all the way through. Whose desk it goes through, what do they do with it, how do they summarize it, how do they put it into a report, what extra information do they get. And we're going to notice all of those input sources and assumptions, transformations. And this is where you get the subject matter experts. And this person here, okay, Sarah Muir, she's a PGO. She was my subject matter expert on this. So any questions on geology I can't answer, it's hers. And so this is your job. This is your job you're going to be up there and you have to try and ask the right questions. And there's Sarah asking the right, or me asking the right questions and Sarah giving me the answers. So that's what we're going to do. So your subject matter expert is definitely your friend, and you've got to be in the same room all the time. Now, this is what came out of when we talked with the subject matter experts is, all right, so we've got this well log data, and all right, geologists, what do you do with it? What do you get? So this data information that they've got there in the center column, they're looking at gamma ray traces and neutron porosity and all this other well log data. And I asked them, what do you do with this? How do you look at it? And when you finish with it, what output do you give? And so what I've highlighted there is, well, they come out with, in this, we're just going to look at the lithology, like the layers of the rocks, and the geological tops, like where in this layer, where is the top of this particular thing? Now, what that is fed, if we follow that, we say, okay, now what happens with that? Where does it go to? That now becomes the data and information for other disciplines within the company. So the geophysics people will say, great, now that I've got geological tops and lithology, I'm going to get this gamma ray data and other things from the well log data, and I am going to add other things to it. I'm going to use it for doing seismic stuff. I'm going to be doing things that are to add value, to build value for this data. And so all sorts of other people are going to use this as well. There's a drilling engineering. What are they going to do with this stuff? Well, they want to know what casement placement is. They want to calculate cement volume, the weight on bit, penetration stuff. That's the other thing that they're going to augment this data with. And the geologist will pass that information on so they can make more intelligent choices. And eventually this gets all the way down to production engineering, where they get there in blue for reservoir engineering and the production engineering is the economics of the well and the production rate expected. So there's the value in getting this pipeline well managed. So we're going to scope this project. So scope this project might have started off as, I want to predict lithology from well log data. Great. You have to scope this as far as a business problem goes. And this, we work back and forth with the data, talking to the subject matter expert, putting this together to say, what do we want this project to look like? We know we started off in that little corner in the graph, but we want to get all the way to the end and find out where's this going to go. So we've got, what are you going to work on? What are you not going to work on? Try and prevent scope creep. And there are things in here, and people that understand the statistics and the modeling will understand the consequences of some of the things we say. We want to be able to spot anomalies. We want to be able to find out, is this a reliable recommendation or is it an unreliable recommendation? So there are things that you will hear if you tune your ears, that you'll be able to hear. So let's look at this transformational process for our well log stuff. And we're going to start off with, we're looking at the data to information piece of it. And if you talk to, this is a survey out of LinkedIn for a bunch of petrophysical kind of people, and saying, How much time do you guys spend just gathering the data, getting it together so you can even do your work? And you can see there from the numbers that it's reasonable to say, and back of the envelope quick survey over coffee is, yeah, they spend a huge amount of stuff just trying to find the data. Now here's the attraction: is all of the wells that are drilled in Alberta are required by AES to log their data and file it. And so all of this stuff is available. It's all freely available from AES. For an individual log, you can pay $11.85, includes GST, to get any log that you want. They're nicely formatted as a flat ASCII file. And about the first thing we had to do is we had to have Python parsing of all of that information into different fields. We built a Postgres database specifically designed so that we could pull out the desired data when we wanted to. So we didn't have to go to the raw files every single time. Now, all of these different traces, you see the bottom part of this trace there, those are the individual traces themselves. The stuff at the header are things like who drills it, where is it, what stuff have we logged, what's considered missing, what's not. So there's a tremendous amount of information that's there, but there's an awful lot of work to get it out. So it's one of the first things we did is make sure that was done quickly and transparently. Now let's have a look at, all right, so we pull out a log, and this is data from a well log in the North Sea. So you can see on the left-hand side there's all these different things that they're measuring. Deep reading, resistivity, shallow reading, resistivity, there's gamma ray stuff. There's all kinds of different things. There's caliper things. Now, the first thing that every data scientist is going to have a look at is, well, what about your missing data? Well, that thing in the middle there, all those blank white spots, are the missing data. So it turns into a huge debate. What are you going to do when you have missing data? There's some there that's really, really sparse. Now, we've looked at this an awful lot, and this is the conclusion that we have come to. The reason you don't see data there is it's unimportant. Now, remember that we're trying to use this to predict important things. People know this. So if they have a well log, and these are expensive, are you going to choose to do a particular measurement all the way down the well if you're not interested in it? No, you're not. So missing data in this case, there's another little flag that comes up, is that means it's unimportant to their decision. That's why they choose not to get it. Now, there could be mechanical problems or instrumentation problems, but generally that's what we've found. Now, on the right-hand side, that's the way they're used to looking at it. And what I've marked on there as well is what it is they're interested in looking at. And this is, now the traces on the right-hand side, that's out of the Manville group. This is oil sands data. And what it's got there is that top little line there, well, that's the top of the Manville. Further on down, we've got Clearwater, Wascana, and down at the bottom, we've got Paleozoic. So the geologists are saying that this is what's important to them, and this is what we've labeled. So now we're going to try and get, how do we get all of this stuff to insight? But what we've got here, this is going through some of that data that we saw in the last well log, is some of this data that, although it's available, is not particularly reliable. So we're going to try and use this. Remember, we have to pick a training set and all that kind of stuff. So what I'd like to do is I'd like to model something, and this line is a line that's over here on the right-hand side, is lining up all of the different features in these well logs. What does it look like as you go from the Rocky Mountains on this side all the way over to the Saskatchewan border here? So it's a lot of squiggly lines. But if there's anything I've learned about lithology is that it's laid and flat. And if something is at this particular height in one well, it's going to be very similar on another one. So this allows us to define training sets with what's in this well. Well, it's probably pretty close to what we already know is in an adjacent well that is confirmed. That they call that well correlation. And what we've got there is the bottom graphic is in fact a correlation that's done across the Permian basin, and you can see how they all line up. So if you're going to do a prediction for lithology of something on the right-hand side of that graph, and you've only got the one on the left, you know how to line up the assignments that have already been done on one side of the graph all the way through. So let's go, whoops. So now we're getting that we understand what's going on. We know how things correlate, and we're getting to this wisdom thing. This is what we're set up with, is we want to try and predict what these lithologies are. What are these layers in the rock based on all the gamma and the porosity and all that? And then we find out, well, different geologists are interested in different things. There is no standard. So what I've got listed there is those are lithologies for two different sets of data. In one case, they're looking at sand, sandy shale, shaly sand, shale, coal, and cemented sand. That was for the Manville group because that's what they're interested in. They're looking at different layers within oil sands. Now on the left-hand side, that's a different data set, and they're looking for different things. So in other words, if I have a wonderful predictive model based on one set of data and lithologies, it's not always applicable to another one. Now on the right-hand side, those are what somebody else might be interested in, is the tops, the layers, the intervals between the layers. And those are the tops for the Manville group. Now you put all these things together and you get this graph here on the right-hand side. That is the assigned lithologies, or the layers of the rock, or of stuff as it goes across the province. That's the same section we had on the other one. So this is the problem as it was presented to me. And what I did is, to be all technical about this stuff, what we had to finally do is we've got a multivariate Bayesian recurrent neural net to predict which these lithologies are. And even though some people say you're never interested in your model, well, here's what we are. Here's five-fold cross-validation on our model. And you can see there that our training accuracy is, I'd say it's really good. Nobody really needs to see, how much better this is. As some of the other ones have said, we're at 97%, 97. Does it really matter if we're that much better? Probably not. Probably not at all. Now, here's some other benefits for what we did when we decided to go with this Bayesian net. I'm just looking at the time, it's 6 minutes. Here's what comes out of a Bayesian net. Is what we do, instead of saying this is a particular lithology, it is a sand, is it a sandy shale, is it a shaly sand? What we do is what comes out of the Bayesian model instead is the probability that it's sand, the probability that it's shale, the probability that it's coal. So this allows someone this allows us to build a recommendation engine. Now you keep in mind that this training set, what was going into this stuff, we chose that. And the reason we chose that is that represents the accumulated knowledge and experience of hundreds of geologists who have said, this is a particular lithology, this is what I say it is. So what this application does is it sort of accumulates all of that experience and professional judgment, all in that to say, this is what we think it is collectively. Here's the other advantage of that, is you can look at all these probabilities, and if it sees something that it doesn't recognize in the model, all the probabilities come out to be very low. In other words, if the model starts to fail, the user knows about it immediately. It says, I know right now, today, I don't have to do testing and things like that. I know for this evaluation right now, it's not sure what is going on right here. It's the advantage of the Bayesian model. That's why we chose it. So now we wrap up and we're going, okay, wisdom to impact. Well, where do we get? What do we get out of this thing? It aids decisions. The model has provided feedback on the reliability of how it is. The lithologies are flexibly defined. We recognize that there is no absolute standard. Anomalies are detected and flagged. If there's anything that a geologist gets really excited about is when something doesn't fit, because they go, good, that's what I'm looking for. And over on the right-hand side down there, we've got, what is somebody going to use about it? And those that's a seismic out of Stratton Field in the Gulf, and overlaid on top of that thing, where do those tops go? Like, what are they interested in? Is they can see the layers, and they can see faults. You can see a fault in that one as well. But what comes down to it is, well, what is that line? I want to know what it is. I can join the lineup. So here's our conclusion. This is what we've got. Is we now have a transformational pipeline, and then the technologies are listed below. Is at the beginning, you're looking at internet or industrial Internet of Things and SCADA fields. To turn that into information, we put that into a database, into a SQL database. Knowledge, we're starting to get some dashboard visualization. Some of these traces you can show a geologist and they can just go boom, just like that. So there's the knowledge. We don't have to get anybody, but we've already built value. Starting to get some insight as we get into modeling. Wisdom, that's where the AI is kicking in, is to manage this entire pipeline as it gets all the way down to getting a recommendation. And I'd have to say with the nature of the problem is there will never be a ground truth. It took us a long time to figure that out. If anything, it has to be, this is what we think it is. So just like medical diagnostics, you don't say, this is what the problem is. The best thing you can do is say, these are the three things we think it's likely.
Okay, I'm going on camera soon.
Yep. And the last thing we're going to do is scale it. And I was really pleased about this one is what comes out of LinkedIn is, what else can you use this for? Helium. There's helium, and Daniel Coates, I think you're on this this talk, is glad to see. Yeah, AER has now published this stuff. So if you want to use this pipeline and this logic for looking for lithium, brine, you're looking for helium, you're looking at disposal, you can follow this same thing wherever you are. There we go.
All right. Well, thank you very much for this journey of insight to wisdom through your transformation pipeline. I'm always excited to see when geologic data is put into machine learning. With my background, I always get excited. Anyway, we do have a few questions. So without further ado, I'm going to go to those because at 5 o'clock, I would like to invite all of you to go to the Alta ML room for our closing remarks for today. Okay, now, how can you build skills to better communicate with SMEs in an area where you aren't experienced?
Daniel, okay, great question. Thank you very much. I would say, you have to be humble. I've read whole books on this kind of stuff. I've never taken a geology course, and that's where I have to go to my subject matter expert. There's Sarah. She's very understanding, very flexible, and very patient. and you have to be humble. You can't go in saying, I know everything. You think, no, I know nothing. I'm an empty vessel. And I'm going to keep my questions as, how reliable is that? Why do you look at that? Where do you write it down? What assumptions are you making? Those are all the questions that I'm asking because I need to understand those. What's going on in the geology and what's happening all the way through this process is I say, I've found this. Does that make sense? Does that look good? Like, how do you find that person? Well, you have to go and find them. Go find someone who's receptive to that. And this network, it's a great source of that. It's who's interested. Hands up.
All right. No, thank you. We have time for one more question. Again, I'd like to encourage everyone who has questions to contact Alastair on, he has posted his different ways of contacting him. So without further ado, here's the last question. How do you avoid data leakage between train and test sets? Is there a special splitting used? Since adjacent logs are so highly correlated, this could be a problem.
Actually, okay, that's a data science kind of question, but here's something that I think people haven't quite come to grips with, and this was incredibly useful, is adjacent wells are going to be very correlated. So it's not so much data leakage of in the traditional sense, it's telling you something. And if you know how to interpret that call it data leakage, that's what we're almost counting on. And that's why we can get so good. Because our training set is usually restricted to wells that are directly around about wherever it is that we're having a look at. And the geologists, they all know this. They say, what's your reference well? And they don't use a reference well that's halfway across the province. They choose one probably right close to it. So, and we use that data. And that's one of the reasons our solution can be so accurate.
All right. Thank you so much. Again, feel free to contact Alastair for other questions. And I hope to see all of you in the